All right, here looking at section 4. This is algebraic reasoning. Now, in this section, if I remember correctly, everything we already know. It's just that we're going to really painstakingly go through and explain why we know what we're doing. Okay, all these up here, all these rules, we should know them all already, but we're going to actually have to use them. Some that might be a little bit new or might be difficult to remember are these three down here. The reflexive property. Reflexive property tells us that something is equal to itself, right? And I always joke that these are like big philosophical ideas, x equals x. Whoa, that's crazy. I mean, it's obvious, but it's the reflexive property. Okay, symmetric is similar but different. Symmetric says that if well, here we have a equals b, then you can flip it and you can say b equals a, right? Anytime you're flipping stuff over your equal sign, you're using the symmetric property, right? Symmetric, you think about whenever you look at yourself in a mirror, you're backwards, right? That's symmetric, right? It's the backwards version. And then transitive property. That is similar, or at least it reminds me of the law of, what was it? The law of syllogism. Where was it? Oh, not there. Yeah, the law of syllogism. It reminds me of it because you can kind of put them together like we did right there. So let me go back to where we were. We're saying that if A equals B and B equals C, then A equals C. So I'd say, well, A equals B equals C, and then you connect the beginning and you connect the end. That's the transitive property, okay? Now, these other ones here, we should really know those already. We might have forgotten the words distributive property. Hopefully remember that. Substitution, we know what to substitute means, to plug in, and then the other four. Let's scroll down. Let's look at this. Solve this guy, justifying each step. So this is trying to lead us into proofs. And proofs are sometimes kind of difficult because you just feel like you're having to explain yourself so much. So here we're going to have two parts. We're going to have statements and reasons. And then I draw it like this with a little table. Okay, and again, this is getting us ready to do something that's a little bit more difficult. And then we're going to have little steps here. And it's like we're trying to explain to someone, how do we solve it? So step number one, is to copy down the problem. So we're going to say, well, it's 2x minus 5 equals 13 minus 7x. Well, our first reason then, we're not going to say copy down the problem. We're going to say it's given. Right, that was our first given. That was our problem. Now we think about how do we go about solving this? For me, I would add the 7x. So I'm going to say we're going to add 7x. Here, let me erase that. Let me put it over here. Add 7x. And we can actually do another step. So as long as we're adding, so here, let me write down, my second reason is going to be the addition property of equality. We're going to be adding something to both sides, so we're using the addition property. And you can do as much as you want as long as you're using the same property. So I'm not only going to add the 7x's, I'm going to add the 5 over. This will give me 9x equals 18. Okay. Now, if you didn't want to do all that in those steps, you would just have two different steps. Step 2 and step 3 would both be the addition property. Now that I'm to 9x equals 18, well, the next thing to do is to divide. So I want to say, well, what's my rule there? What rule am I using? I'm using the division property of equality, right? Division property of equal sign, right? And I'm abbreviating here. You're welcome to abbreviate too, but don't abbreviate too much. I'm going to be abbreviating as much as I can. So you don't want to abbreviate any more than I do. So here, step 3, we already said that it's the division property. Well, that's going to be dividing the 9, and that gives me x equals 2. And that's it. We're done. We can just box that in, and there we are. We have our steps. We have everything explained out as to what we did, right? This whole justify each step, that's writing our reasons down. Okay, there we are. Let's scroll down. Let's look at another one. You bounce a pool ball off the wall of a pool table, as shown. Determine whether angle 1 equals angle 2, or the measure of angle 1 equals the measure of angle 2. Now, it's not asking us to prove. It's just asking us, what do you think? Do you think yes or do you think no? Well, so we've got this angle and then this angle. Well, this guy's in the middle. I'm going to say they're going to have to be equal. Right? If you look at the actual swoops that they have there, they say that the measure of angle, we'll say this is arc, I don't know, arc 4. Measure of angle 4 is the measure of angle 1 plus measure of angle 2. Then we'll say that this guy is, we'll say that's 5. Measure of angle 5 is the measure of angle 2 plus measure of angle 3. And we should probably be able to see that this 2 overlaps. 4 and 5 are equal, so yeah, they are going to be equal. Okay, we're not trying to prove it. We're just trying to kind of get us there. Okay, later on in the next section, I believe we're going to be proving it a little bit more rigorously. Next up, example 19. At a local cinema, right, that's a movie theater, there are 2 exits along the same walls of the theater. Along that same wall, there's a trash can that is the same distance from each of the 2 exits. Show that the distance from the trash can of the left exit is half the distance between the 2 exits. Well, it says to show that, so I'm going to draw a picture. So we've got the back wall. At least I assume it's on the back wall. I don't know. We got our trash can there. We've got our wall. We've got another wall. This here is X. That there is also going to be X, right? These are doors. Door. Right? And the trash can is supposed to be perfectly between them. So the distance from door to trash is X. The distance from door to door is 2x, right? If you add them up, you'd have 2x. Now, to me, right there, that's showing that it's half, right? 2x divided by 2 is x, right? So I'd say that's it. That's us showing it. Again, later on, we'll show that a little bit more rigorously, but hopefully we're able to see that, right? The distance between these 2 guys is half the distance of that, the whole thing. All right, that's example 19, and we are done. So again, let's look at these. There's going to be quite a few of these on homework. Make sure that you're doing your little statements, your reasons chart. If you want to abbreviate, you can say S and R, but we need to make sure that we have these numbers for them to say which step it is. And you also want to keep your numbers kind of even. You see how my 1 and my 1 are relatively even, 2 and 2, 3 and 3. Try to keep those even. It's okay if you do a little bit of work in the middle here, right? We divided those out. That's okay. But make sure you try to keep them even. Don't make one of them really, really short and the other one tall, okay? Right? I left some space in here just to keep it even with the other one. Okay, so we want to make sure that we're trying to do that. All right, there we are. That was section 4.